Yeah, till now, gentlemen, we have been studying about the vapor compression cycle as used on board vessels for refrigeration purposes. Today, we will deal in a brief manner about how you go about drawing the pH diagram or understanding it in the simplest way possible. So, first, let us just brush up the vapor compression cycle a little bit. From the diagram, you can see that the gas which comes back after the evaporator enters the compressor where it is compressed, and along with it the temperature of the gas increases. After that it is taken to a condenser where it is brought down to its liquid form at constant pressure. These are the bases on which this pH diagram will be drawn. So please remember this. It is brought into its liquid form, and after that it goes to the expansion valve where its pressure reduces, and then on to the evaporator and back again to the compressor. This is the simplest way. Now let us take into account what happens when the gas comes out from the evaporator. It goes to the compressor in a cold state. Repeat, the gas is cold. So when the gas is cold and its pressure is also the least in the cycle, as it enters the compressor, it enters as the least pressure and the gas is cold. This tells you that the energy or the enthalpy that the gas will be carrying as it enters the compressor will be the least. Now after the compressor, we know that the gas is going to get heated up and the pressure also rising. So there will be a high amount of energy inside the gas, meaning the enthalpy will be very high. Next it goes to the condenser where heat is taken out. Repeat, heat is taken out but at a constant pressure. Repeat, constant pressure. So when the heat is taken out, the enthalpy drops. So we have a lower enthalpy in this zone. After the condenser, the receiver can be passed for the pH diagram alone, and then we enter the flow control or expansion valve where this liquid which is coming out from the condenser is going to expand into a lower pressure zone. Okay, into a lower pressure zone. Repeat, here the pressure is low. Generally, sir, the expansion valve and this expansion is considered an isoentropic process. So if you remember this, and after that it enters the evaporator coil where the liquid refrigerant gathers a large amount of heat from the room and converts into gas as it leaves the evaporator coil, and its temperature is cold as it enters the compressor. If you have followed the energy levels now, I have explained everywhere where the energy drops, where the pressure drops. You could easily figure out how the pH diagram would be. Before we go to the diagram, here it shows very clearly the line A to B represents the change from high to low pressure or expansion process. So he starts this at the expansion valve. Okay, here we go. Let's check the next diagram. Okay, sir, the line A to B represents the pressure change as the liquid from the condenser is entering the evaporator coil. Okay, expansion is taking place in this line over here. Expansion takes place, and the liquid after expansion enters the evaporator coil. And after entering the evaporator coil, sir, it absorbs the heat from the room. Repeat, as it absorbs the heat from the rooms, its energy levels are going to increase. This is done again for all practical purposes at a constant pressure. So, during the evaporator coil passage of the refrigerant, the energy as it is absorbed is constantly increasing. So you can see this is the enthalpy, and the energy levels are constantly increasing, but the pressure is constant until it reaches the compressor. Now at the compressor, compression is taking place. Obviously the pressure is going to increase, and the enthalpy also, as the gas is going to get heated up in the compressor, the energy levels will increase. That means the enthalpy will increase. So the next stage of the curve is pressure starts increasing like this, and you can see that the enthalpy is also increasing until it reaches the outlet of the condenser, from where at constant pressure it goes into the condenser. It goes into the condenser. After it goes into the condenser. Okay, so now the hot gas from the compressor is going to enter the condenser, where it is going to liquefy. Repeat, now it is going to cool down and convert state in the condenser. So definitely the cooling down is going to result in a lowering of the energy levels in the gas or the liquid, and thereby lowering in enthalpy. So you can see over here, the condensing is at a constant pressure. So at the end of the compressor, when it enters the condenser, the energy keeps dropping. It converts into liquid. All this is at a constant pressure over here. So it keeps converting at a constant pressure, and then it once again in the liquid form reaches the expansion valve, where it will restart this cycle of the same cycle will repeat after it enters the expansion valve. So the BH diagram is pretty easy to draw. Gas entering the compressor is at its least energy levels and lowest pressure. When it exits the compressor, it is at the highest pressure and highest energy levels. In the condenser, the energy levels keep dropping, and the pressure remains constant. Then in the expansion valve, it expands into a lower pressure with energy levels fairly constant. I think this should be easy enough for you to have followed to draw a pH diagram in its simplest state. Any doubts? You may please ask. Thank you.